Hey guys, so I want to talk about something called an arithmetic sequence. Okay, so when we think of the word sequence, we think of something happening over and over again, a pattern. Well, an arithmetic sequence is a pattern of numbers. For instance, 3, 7, 11, 15, and so on and so forth is considered an arithmetic sequence, and this is why. We have a common difference. So between 3 and 7, I add 4. Between 7 and 11, I add 4. And between 11 and 15, I add 4. So when you see a common number between each consecutive number in the sequence, we know that it is in fact a arithmetic sequence. Okay? That number is called a common difference. Now, in math, we use the letter D to indicate the common difference. So the common difference of this arithmetic sequence is 4. So if I wanted to find the next term of the sequence after 15, all I would do is add 4, and I would get 19. So there's more than just the common difference. There's a few things we have to know. With an arithmetic sequence, there's the first term. Okay? 3 is the first term of this sequence. Anytime that we indicate the first term, it's A is the term sub 1. That little subset of 1 indicates the first term. Now, we also have something where we can say like A sub n. And so n can represent any term. So if I want to find, let's say, A sub 3, what this here means is I want the third term of the sequence. So 1, 2, 3. So the third term is 11. A sub 4 is 15, and so on and so forth. So there is a formula in order to get the next term and the next term and the next term and the next term. Okay? This is called a recursive formula. So a recursive formula is beneficial when you want to find like the next few terms in the sequence. So I'm going to rewrite my sequence from before: 3, 7, 11, 15, 19, and so on and so forth. From this, I can pull out my first term, which is 3, and I can pull out my common difference, which is 4. Those are really important in the recursive formula. The recursive formula is written like this: A sub n is equal to A sub n minus 1 plus D, the common difference. What this means is whichever term we are looking for, the nth term, let's say it was the 5th term, you can find that particular term by using the term right before it. So 5 minus 4 by using the 4th term. So it's important that we know what A sub 1 is. So when we are using this formula, not only do we use that, but we also specify what A sub 1 is. Let me show you. So again, we have 3, 7, 11, 15, 19, and so on and so forth. the recursive formula in general looks like this. So these is the pieces of information that I have to input in order for it to be specific to this particular sequence. I have to input the common difference, and I have to tell you what the first term is. So for the recursive formula of this, it would be a sub n is equal to a sub n minus 1 plus 4, and then I would say that a sub 1 equals 3. This is the recursive formula for this specific sequence, arithmetic sequence. Let's look at another one. Let's say I have 5, 3, 1, -1, -3, and so on and so forth. So if I want to write the recursive formula for this, the information that I need is the common difference and the value of the first term. Well, the value of the first term is easy. It's 5. So a sub 1 equals 5 is going to be part of my recursive formula. But the common difference is not as easy, so I have to figure out what that is. Well, if I go from 5 to 3, I've subtracted 2. 3 to 1, I've subtracted 2. 1 to -1, again, subtracted 2. And -1 to -3, I subtracted 2. So my common difference is a -2. Instead of saying a plus minus, I'm just going to say -2. And this is the recursive formula that will help me to find any value or any number in the sequence that comes pretty soon. Why don't you pause it and try for this one? Okay. First thing though, you do have to make sure that it is an arithmetic sequence. For instance, 4, 8, 16, 20, and so on and so forth. As I'm going up, I see +4, but then here is a +8. Right then and there, I know that this is not an arithmetic sequence because there was no common difference. So please make sure that you always check to make sure there's a common difference before assuming that it is an arithmetic sequence. All right, so I want you guys to try this one. All right, so I want you to write the recursive formula for this sequence. So I encourage you to pause, try it, and then play it to make sure that you got it right. So let's first start by seeing if this is in fact a recursive formula or a recursive sequence. 7 to 4 is a -3. 4 to 1 is also -3. 1 to -3, I believe, is -4. So this is not a recursive formula. We couldn't have done it. So there is no this is not an arithmetic sequence. We couldn't have done it. So unfortunately, we can't make a recursive formula. Try this one. Okay, let's see. 15, 22, 29, 36, ... Again, pause, try it, and then play. So this one is going to be a recursive formula. From 15 to 22, I've added 7. 22 to 29, I've added 7. 29 to 36, I've added 7. So my common difference is 7. The first term of my sequence, a sub 1, is 15. So, because the recursive general formula looks like this, a sub n equals the previous term, so n minus 1, plus the common difference, and then we list what the first term is, I can rewrite this specifically for this sequence by saying a sub n equals a sub n minus 1 plus 7, and I can say a sub 1 equals 15. This is the recursive formula for this arithmetic sequence. So that's helpful if we want to find the next term and the next term and the next term. But it can be exhausting what if we want to find the 500th term? We can't just keep adding over and over and over and over again. So there's another formula for that. It's called the explicit. Explicit. E-X-P-L-I-C-I-T. Okay. I'm not really good at spelling, but the explicit formula. All right, and so this formula is going to help us to find not the next, but one that's further away in the sequence, whichever nth term we're looking for. So if I want the 5th term, I'll put a 5 in for n. If I want the 1000th term, I'll put 1000 in for m. So the explicit formula is a sub n equals a sub 1 plus the common difference times n minus 1. So what this means is the nth number I'm looking for is equal to the first term of the sequence plus the common difference multiplied by n, so whatever I put in for n, minus 1. So let's look at an example. If I gave you 2, 5, 8, 11, and so on and so forth, first I want to see, does this have a common difference? 2 plus 5 is 3. 2 plus 3 is 5. 5 plus 3 is 8. And 8 plus 3 is 11. So the common difference is 3. The first term of my sequence is 2. So using this general formula here, I'm going to fill in all the things that I know specific to this sequence, which is the first term and the common difference. So a sub n equals a sub 1, which is 2, plus 3 times n minus 1. This is one way you might see the explicit formula. But because you can use the distributive property, sometimes you might see it like this. I'm going to distribute the 3 into the parentheses, and then I'm going to combine like terms. So a sub n equals negative 1 plus 3n, or 3n minus 1. This is the explicit formula. It can help me find any numbered term in the sequence. So I have the first, the second, the third, the fourth term. If I wanted to find the 5th term, I would probably use the recursive formula because it's the next term, but let's just see. If I did use the recursive formula, 3 more than 11 would be 14. So I should be getting a 14 to find the 5th term. So let's see. I'm going to use this one up here. So I'm looking for the fifth term. So I'm going to plug in a 5. That's equal to 2 plus 3 times 5 minus 1. Well, that's equal to 2 plus 3 times 4, because 5 minus 1 is 4, which equals 2 plus 12, which equals 14. So as you can see, the fifth term is in fact 14. But I can use it to find any. So let's say I wanted to find the 20th term. So again, here's my explicit formula. The first term was a 2 plus 3 parentheses n minus 1. Well, if I want to find the 20th term, I'm just going to plug in a 20 for n. So 2 plus 3 times 20 minus 1, that's equal to 2 plus 3 times 19. 3 times 19 is 57, so that's 2 plus 57, which is 59. So the 20th term is equal to 59. So a sub 20 is equal to 59. Let me do another one. Let's say I have 8, 3, -2, -7, and so on and so forth. Let's see if this is an arithmetic sequence. So 8 to 3, you subtract 5. 3 to 2, you subtract 5. 2 to 7, you subtract 5. So we have a common difference of -5. And the first term of our sequence is 8. So plugging it in, I get a sub n equals the first term, which is 8, plus our d value, which is -5, times n minus 1. Cleaning it up just a little bit, I get a sub n equals 8 minus 5 parentheses n minus 1. If I want to find the, which term is that? It's the 50th term. If I want to find the 50th term, I'm going to plug in 50 anywhere I see an n. So a sub 50 equals 8 minus 5 times 50 minus 1, okay, which equals 8 minus 5 times 49. Well, 5 times 49 is 245. So this is equal to 8 minus 245. And 8 take away 245 is equal to -237. So the 50th term of the sequence is equal to -237. Makes sense because it keeps going down and down and down, so it makes sense that it's such a large negative number. All right, last one I'm going to have you try. So given this sequence, okay, I want you to tell me what is the explicit formula. Okay, try it. Pause it for a moment. Try it on your own. I'm also going to include the recursive formula just for a little bonus. So let's start with the explicit formula. So to get from the first term to this term, I went down 20. From here to here, I went down 20. And from here to here, I went down 20. So my common difference is negative 20. The first term of my sequence is 54. So if I want to put this in an explicit formula, a sub n equals the first term, which is negative 20, plus the common difference, which is 54, times n minus 1. So that's the explicit formula. If I want the recursive formula, a sub n equals the previous term, which is a sub n minus 1, plus the common difference, which is negative 20. So instead of plussing negative 20, I'm just going to subtract 20. Okay, and then I also have to list what my first term was, which is 54. Now I can use this to find either the next term or a term way far in the sequence. So if I was looking for the fifth term, I'd use the recursive formula because all I'd have to do is subtract 20 from negative 6. But if I'm looking for like the 20th term of the sequence,